Okay, so welcome to a look at some lack of penetration. And lack of penetration, you know, in a single V-groove weld like we're going to be doing here, you got the OD and the ID, and a gap at the root that is usually fairly narrow, could be a 1/16 or up to 3/16. And we have our, if you can see them there, these dotted lines for our 30-degree bevels. And most of these welds, when they're fairly thin walled, will have a root pass, a hot pass, a couple of fill passes, and then a cover pass. And ideally, this root pass should penetrate all the way to the ID and even maybe have a little extra internal reinforcement. But when you have lack of penetration, then neither of those corners are melted. And we're going to take a look and see what this looks like on one of our samples. And, you know, we're intending to do everything here for thin-walled steel pipe. In this case, this piece is a little bit thicker. It's the only LOP I had access to. And it's about 7/10 of an inch thick, so we're going to do a few things that are a little different. All right, let's get started with our straight beam. Okay, so here we are with our straight beam. Let's go ahead and I've recalled our straight beam cal, SB for straight beam. And let's go ahead and check this. And I'm just going to check the 200 step and the 500 step. And let's see, auto, second function auto 80, 200, and go to the 500 step. Second function auto 80, 500, so that is good. And our flaw is going to be in this neighborhood here. And I think did I mention this is about 7/10 of an inch thick? Let's crank that up a little bit, get enough gain in there. So I think our thickness is pretty consistent. Around, I'm going to call it 705 for a wall thickness on both sides. And let's see if we can get an idea of how thick you think this pipe is. And I think this is our back wall signal over here. I'm going to add quite a bit of gain and get that up into the gate. And I'm going to say that I'm seeing that at about 840, maybe even 825 deep. So I'm going to call it 705 wall, 825 weld thickness. I'm going to take my contour gauge. I happen to know the flaws in this neighborhood. I'm going to transfer this over onto my indication plotting. Alright, so I've gone ahead and transferred our profile contour. Our thickness is 705. I've put in the thicknesses we know in solid lines. And we got a pretty good idea that the ID should look something like this. And measured from the outside surface, it's about 825 or possibly a little thicker there at the root in the unflawed areas. Alright? And let's go ahead and get ourselves set up for a fast scan. And for a fast scan, you might recall that to get a good setback distance to direct the sound to the root of the ID, you would use the surface distance formula, 2.75 times the thickness. 2.75 times, well, we've got 705 wall. So our setback distance to set up so that we're looking at the root at the end of leg 1 in a half V at the end of leg 1, our index point should be 1.94 inches back from the center of the weld. So let's go ahead and set up some lines on the part for that. Alright, so I'm going to set up some setback marks on the part. I'm going to call this our center line, more or less right there, and I want to be 1.94 back from that. So I want to be there on that side, and I want to be here on this side. And I'm going to take the liberty of putting these lines down in Sharpie so you can keep using these lines to do various scans on the part. Hopefully, as I'll say. So that's where we're going to have our index point for our setback fast scans. Alright, let's get ready to do a fast scan. I'm going to recall my fast scan for my this is actually a Sonatest Q-Scan 1 probe. Works similar to the Fast Model 1 probe. These types of probes are really good for material less than a half inch thick. And we've got something here that's about 700, about 0.705, 7/10 of an inch thick. So that's really not the ideal angled L-wave probe for something this thick. But I'd like you to see what it looks like with the probes for the thinner material, and then we'll try it with a more appropriate angled L-wave probe, the Fast Model 2. But let's go ahead and recall our Fast Model 1 cal that we're going to use with our Sonatest Q-Scan 1 angled L-wave probe here. So okay, so now we've checked it at the 4/10 deep hole. On this half-inch thick thin-walled cal block that we've been using for the most part, I can't use that with an angled L-wave probe because I can't bounce into a hole to make the machine think it's 7/10 of an inch deep, because you really don't get a good bounce with the angled L-wave probe. Now I happen to have another block that's 1.5 inches thick, so I happen to have a 1/32 diameter side drill hole that is 7/10 of an inch deep. So I'm going to go ahead and use that, and I'm going to have to add quite a bit of gain. So I'm going to call that good. So now we're ready to do a couple of fast scans here, and I'm going to use my magnetic guide tape. I want to put my index point right on the mark that we previously made for our setback scan. And let's see what our setback scans look like from both sides. And this is clean material, and now we've got something. Now we're off it. Let's go back into it. Yes and no. Start, stop. Let's try that from the other side. And here we go, nothing, and yes, and stop. Start and stop. Alright, I'm going to mark that up with some yellow chalk. I'm going to say it starts right about here. And ends about here. And I'm marking that right to the center of the transducer. Let's try this from the other side. And you know what, let's try this butt up this time from both sides. And jammed right up against the weld. You know what, it's actually easier to see it. So I'm going to have a start up right there. And an end of right there from this side. And let's do that butt up scan from the second side. Yeah, it starts just about the same place we had it marked from the setback scan. Yeah, same spot pretty much. All right, let's see what this looks like with an angled L-wave probe, a fast probe that is more appropriate for something thicker than a 1/2 inch thick, which would be the Fast Model 2 probe. So let's go ahead and set up with that now. All right, so now we recalled our cal, we checked our cal, we went to a 7/10 of an inch deep, 1/32 inch diameter side drill hole. We brought our gain up to about 50% screen height. So we're ready to go. Okay, let's repeat these setback scans. freeze, and here we go. Yeah, and that's the end of it. Let's go back into it. Yes, 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 and that's the end of it. So that coincided, but it looks much clearer where the flaw begins and ends with the fast model too. Let's try this from the other side. And here we go. Yeah. And that indication coincides with the same spot. Let's try this as a butt-up scan where we're jammed up right up to the toe of the weld. And that agrees with what we had already marked. And I'm going to point something out here. As I slide by the flaw, that L-wave signal stays there pretty much set on one spot on the screen. It doesn't walk back and forth. And that's because the edge of an LOP is a machined edge. And it's very straight. So the flaw should not move much left and right on the screen. So that makes sense. And if you don't have an angled L-wave probe, you could repeat this using a 7D shear as a detection scan. So let's go ahead and set up for that. Alright, and I'm going to use the same thing to set my gain. And because I have this 1.5 inch thick block, I'm going to go ahead and shoot that. And this is our signal right here. So I'm going to bring that to 50% screen height. Right about there. And these other signals out here, those are due to this being a short approach wedge. You know, I can damp those out with my finger. Those aren't really real. You can always make those go away. All right, another way to do this, because it's a shear wave, is you could use your 1/2 inch thick block and bounce into the 300 thousandths deep side drill hole. Because to bounce into it, you're going to go down 500 and up 200. That'll make 700 deep. So let's see what that looks like over here. And that looks pretty similar. And then that 700 deep, 50% screen height. Alright, so let's set up for a setback scan. I'm going to use that same scan line. And here we go. Wow, that was really loud. Start and stop. Let's try that from the other side. So it agreed with the same starts and stops that we had with fast. So you can substitute the 70, excuse me, for the detection scan. Start and stop. Start and stop. So our detection is good. So now we want to figure out what we have. And we've already seen it with 70 actually. Let's go in and look at that again. And it's quite a bit of gain. If I make those standing waves go away, you can see here, this initial little signal here is really the signal from the flaw, and it has a very fast rise and fall time. Let's try that from the other side. And it really does, most of that sound peaks up near 700 deep, so it does look ID connected. Alright, let's look at this with 45, and then the 60 I think on this one is going to tell us the most, so we'll save that one for last. But let's go to the 45 now. Alright, now we've got our 45 recalled in here. And let's see what we can see in here. Yeah, we got something really loud in there. And it holds rock steady as far as left and right movement goes. Let's see if we can peek up on that. You know, we jam into that weld. We really can't peek up on it. Let's try that from the other side. Yeah, we can't quite get in close enough to peek up on it. But let's try a trick that I think we used for another flaw somewhere else. Let's use the end of the third leg. So I'm going to tune in the thickness of 700. 705 actually. Alright, so we have 705 tuned in for thickness. And let's change our view to be a leg display view so we can see a little more than 3 legs. Because we should be able to get in a little bit closer if we don't have the wedge hitting the weld. So let's go into our display settings and we'll change it from standard mode to leg mode. And right now we're only seeing L1, leg 1. Let's increase our range so we can see a little more than 3 legs. And so I'm going to touch range and start to increase that range. Leg 1 and 2. Okay, here comes leg 3. Alright, let's go in there and take a look at this now. And this is back where we were. Now we're getting it at the end of the third leg. This is when we were jammed up to it, and we can't pick up on it in leg 1, but let's see if we can pick up on it out near the end of leg 3. And we're on it. And we are peeking up on it. And when we go side to side, it does hold rock steady. And I'm going to add some gain to see if I can see something like, it looks like a tip signal walking over the top. And I think maybe I do here with this. The taller signal is going to give me the corner, and the one in front of it might be when we're walking over the top of it. Could possibly use that for some sizing. Let's try that on this side. Here we are at the end of leg 3. I'm going to push up to look for a tip, and from this side I'm really not seeing it. Alright, so far with everything it looks ID connected, and it looks like it stays a set distance from the probe when we scan side to side. Let's look at this with the 60. Alright, so we have our 60-degree cal recalled, and I'm going to go to this 7/10 deep side drill hole, and that's 50% deep. I'm going to set my reference dB, and instead of having surface distance minus vex value, I have surface distance, so I've got to measure everything from the index point, not from the front of the wedge. And let's go ahead and take a look at this with the sound going from my right to my left. And I see some other indications that come up that are a little bit confusing, but this one in the back here, this tall one, that's got to be the lack of penetration. And let's see where that plots up to on the surface. So I'm going to take some gain out so I'm gated on that color signal in the back. Okay, my surface distance is 1.39. 1.39 measured from the index point. 1.39. That brings me to here. and let's do that from the other side. I'm going to put my gain back in, back at reference. And I'm going to walk that to 7/10 of an inch deep. And that's my flaw. Alright, let me check my surface distance here. 1.21 from the index point. 1.21. That goes to here. So that gives me a gap of about 3/16 of an inch there, which is normal for lack of penetration. The sound does not, the surface distance does not plot to the same point on the surface. It comes up a little bit short because the corners are two different distances away. Alright, let's take some data with the 60 from both sides. Alright, let's take some data here with our 60 for indication plotting. And let's look at this side here with the sound going right to left first. And let me get my gain back up to reference dB. And I think this tallest signal here, I think this is my corner trap signal at the ID. So I'm going to put it to the ID at 705 deep. And I'm going to take 6 dB out because there's some noisy stuff at the bottom. I just want to be plotting to that signal only. And alright, so the distance from the toe of the weld to the index point is 0.78. And then let's see, I can freeze this. My sound path is 1.4. My surface distance is 1.2. And let's try this from the other side. Come on. Okay, so that's our corner signal. I'm going to add 6 dB of gain. Oh, I'm already 600. Get it back to reference. That's a little better. Alright, so I'm going to walk that to the ID about 705 deep. And let's measure from the index point to the toe of the weld. And I get 0.95, and then I can freeze it and write down these other numbers. Sound path is 1.4, surface distance is 1.2, and while we're over here on this side, let's try and do some flow height sizing. This is my corner. I'm going to try and walk up the face of the flaw. And I think this signal in front over here, I think that's my tip where I go over the top of the flaw. And the depth where I go over the top of that, I'm going to say is right around there. Around 512. Alright, let's go ahead and plot this out. Alright, let's go ahead and try and plot this. So I've got some data taken with the sound going from right to left and some data with the sound taken going from left to right. Let's start with this right to left data. Let's see, the distance from the index point to the toe of the weld was 0.78 from this side. 0.78, so right from there. And our sound path is 1.4. I want this 45, 60, 70. I want this 60, but I want the sound going this way. And our sound path is 1.4. So reading along here, quarter, half, 3/4, 1, 1 1/4, 1 1/2. So 1.4. So the idea is right about there. And our surface distance is 1.2. 1.2. So that lines up okay. Let's try it from the other side. The distance to the toe of the weld from the index point is 0.95. 0.95, right about there. Our sound path is 1.4 on the 60 line. Quarter, half, 3/4, 1, 1 1/4, 1 1/2. 1.4 is right about there. Right about there. Our surface distance is 1.2. Right about there. So our LOP is going to be like so. And the tap of the LOP, let's see, it's going to be 0.51 inches deep to the tap of the LOP. 0.51 inches deep. The LOP is going to look like this. There's no root, there's actually no root in there. And let's see, if this is 0.51 inches, and our thickness is 0.705, 705 minus 510 is 9 minus 1 is 8, 6 minus, so our flaw height is 185. All right? Okay, thanks a lot.